All right, so here we want to talk about adding and subtracting fractions. And this is where we kind of start not to like fractions a little bit. But what we want to look for when we're adding and subtracting, as opposed to multiplying and dividing, we need to look and see if the denominators are the same. If they are the same, that actually makes us really happy. It's a lot less work. And how we add and or subtract fractions is what we do is we take the top part, and in this case it's addition, so we add them. But the denominator stays the same. So we don't add the denominator, we only add the numerator. So 1 plus 5 gives me 6. And it stays over the denominator of 3. But remember, we always have to simplify our fractions. In this case, 3 divides into 6 evenly, which just gives me 2. Right. If we look at the subtraction that's below, instead of adding, now we take 1 minus 5, and that stays over the same denominator, which is 3. And 1 minus 5, now remember, this is going to follow our integer rules. It is as if that denominator is not even there. So 1 minus 5 is negative 4, as per our integer rules, and it stays over the denominator of 3. Now in this case, it can't be simplified, so we're just going to leave it the way it is. Now when we're writing our negatives, we usually like to write them on the top so we make sure we know it's negative. Some people may go ahead and write it like this. Just be careful that your negative sign does not bleed into or look like it's a part of your division bar. But both of these are equivalent. All right, let's look at something that's a little bit longer. All right, I have 5 over 6 minus 3 over 6 plus 7 over 6. Now I know I showed you the trick in multiplication and division that you could simplify a fraction. In this case, we don't want to because we 100% need to have these stay the same. And they're already there. I don't want to create more work for myself. So in this case, my denominator is still going to be 6. It's going to stay there. On the top, I have 5 minus 3 plus 7. And that's a separate operation. So we got 5 minus 3. That's going to give me 2. And then take that 2, add the 7 to it, I get 9. And then that 9 is going to be over 6. Now remember, I still have to simplify my fractions. 9 and 6 have a 3 in common. Remember, 9 is 3 times 3, and 6 is 3 times 2. And because I have a like number on the top and on the bottom, I can go ahead and cross them out, and my answer here is going to be 3 over 2. Okay. Now when we're going ahead and talking about this idea of common denominators, now we know if they're already there, we just know to go ahead and take care of it. But sometimes we have to create our common denominators because we don't have them to start off with. So what you want to think about your denominator as being is, let's go ahead and say I take a pizza, and my denominator is going to represent my number of slices. So in this case, I cut my pizza into 4 pieces. And if I go ahead and eat one of those pieces, that's a large piece of pizza, I have eaten 1 piece out of 4. Right? And the whole idea of creating common denominators is basically we want to change the denominator to represent the other denominator that's with it. So our denominator will always be our largest number in our problem or bigger. Okay? So in this case of 1/4 plus 2 over 8, 8 is my largest denominator. Now, if I can multiply the 4 times something to get 8, I can create what's called an equivalent fraction. I can add them. They'll have the same denominator. So if I want to take this fraction 1 over 4, and I want to create an equivalent fraction of 1 over 8, what is really happening here is now we want to, instead of have a pizza in 4 pieces, we want to put it in 8 pieces. But I'm going to eat the same amount of pizza. Now we notice now in the blue section, now we have a total of 2 pieces. So that means that now, out of 8 pieces of pizza, I ate 2. And how we got to that point was going ahead and multiplying the 4 by 2 to get the 8, and whatever we do to the bottom, we do to the top, which creates our equivalent fraction of 2 over 8. Right? So if we go ahead and see a problem like what we have below, and I see I have a 4 and I have an 8, I can make the smaller denominator into the larger by multiplying it by 2 like we did above. Which means now that my problem becomes 2 over 8 plus 2 over 8. And here now we have like denominators. That makes us very happy. So we're going to keep a denominator of 8. And on the top we have 2 plus 2, so our answer is 4 over 8. Now we know we have to simplify this fraction. And I have 4 and I have 8, which means I ate 4 pieces of pizza total out of the 8. So if I were to go back in and color 4 pieces of pizza out of 8, I ate half a pizza. Okay, so 4 over 8, I can divide top and bottom by 4 or change it to my multiples, and I ate a half a pizza. Okay, so this is the whole idea of common denominators. We're trying to make the fractions into equivalent fractions so their denominators are the same, so we can go ahead and add those together. Right, let's go ahead and look at these 2 problems. So here I have a 12 and I have a 4. Now I know if I'm looking for something called my LCD, which is what we called getting common denominators, my lowest common denominator, I want to see if I can create and multiply the 4 by something to get to 12. In this case, if I take my 4 and multiply it by 3, I get 12. So my LCD in this case is going to be 12. So I'm going to go ahead and multiply the top and bottom of my fraction by 3, which is going to give me 9 over 12 plus 1 over 12. Here I keep my denominator the same because they're the same now. I have 12. 9 plus 1 is 10. And this fraction can be simplified by dividing top and bottom by 2, which will give me 5 over 6, and I am done. So once you're done with your addition or subtraction, your denominator, once you simplify, may not be the same. Right? What if we have it to where our denominators are not alike at all? So here, I have a denominator of 3, and I have a denominator of 7. I know my LCD has to be greater than or equal to my largest denominator of 7. Right? And I want to look and see, can I multiply 3 by some number to give me 7? That can't happen. So our next step is we're going to go ahead and take, and our LCD is going to be these 2 numbers multiplied together because they have nothing in common. So 3 times 7 is 21. And therefore my LCD in this case is going to be 21, which means each of the fractions has to be multiplied by the other denominator. So my 5/3, I need to multiply the top and bottom by 7, which gives me 5 times 7 is 35/21, and that's my equivalent fraction. Now for my 2/7, this one I have to multiply top and bottom by the 3, which gives me 6/21. So my new problem with equivalent denominators with my LCD is 35/21, which is my 5/3, minus 6/21, which is my 2/7, and 35 minus 6 is 29, and the 21 stays. Now, because I had nothing in common to start with, good chances I won't be able to simplify that, and 29 is also prime, so in this case, I am finished. So common denominators, okay? Your common denominator will never be less than the largest denominator. So look for that largest denominator and know that your common denominator will not be smaller than that. Second best thing is see if you can make that smaller denominator into the largest denominator by multiplication. If you can, that's the next best scenario. If all else fails, you need to go ahead and multiply those denominators in order to get your LCD because there is nothing in common. Okay, so here we have, again, 4 and 12. All right, so if I want to add these two numbers, I'm going to go ahead, multiply by a number. I know my LCD must be 12 or greater. Can I multiply the 4 into something to give me 12? Yes. I can multiply it by 3, like we did previously, which means I have 3/12 plus 1/12, which is 4/12. We have seen this fraction before. I can simplify by dividing top and bottom by 4, and I'm going to get 1/3. And I'm done. If we have something that looks like this. Now this is a slightly different version of the 3 rules we talked about. First of all, we know our LCD must be greater than or equal to my largest denominator of 12. Right? In this case, can I multiply 8 by something to give me 12? That's number 2. But in this case, they have a number in common with each other, so I don't necessarily want to multiply the 8 times the 12. That's going to make my numbers really big. So let's talk about what happens when you see something like this. All right. Now you certainly could multiply the denominators together and it certainly would work, but it wouldn't be your LCD. It's going to be a number bigger than your lowest common denominator or the lowest number that they have at one time. So let's go ahead and look at 8 and 12. So 8 is 4 times 2. If I look at 12, 12 is 4 times 3. Now they all both have this 4 in common. So they already have something in common with each other. What they don't have in common with each other is the other 2 numbers. So if I want to make the 8 and the 12, and I want to make this area here the same, what I want to do is I want to go ahead and say, okay, well, the 8 will need a 3 that the 12 has, and the 12 will need a 2 that the 8 has. And each of these 2 sections multiplied together will give me my LCD. So in this case, my LCD is 4 times 2 times 3, So I have 8 times 3, which is 24. So 24 is my LCD. The numbers that are in green represent what I need to multiply each fraction by to get to my LCD. So my 1/8 needs to be multiplied by 3 because that's the number in green. That's the number I added in there. When I do that, I get 3/24. Now my 3/12, okay, going to be multiplied by 2 because that's the number in green that I needed, which gives me 6/24. This is addition, so my problem is 3/24 plus 6/24, which gives me 9/24. Now, does this simplify? It does. Okay. If you go ahead and divide top and bottom by 3, my answer is going to be 3/8. Okay. And you may see a different way to do this. And if you do, fantastic. But no matter what you do, you should end up with 3/8. If you see the other situation, give it a try and try it out. But if you have two numbers that have only a piece of them in common, it is good to kind of do a little chart for it if you can. All right, so unlike denominators, again, we have our 5 and our 7. All right, which means 5 and 7 are not alike at all. So my LCD in this case is going to be 5 times 7, which will be 35, because 5 and 7 are prime. So that means my 1/5 and my 1/7 need to be made into equivalent fractions. The 5 will be multiplied by 7 top and bottom, and the 7 will be multiplied by 5. Okay. When I multiply straight across, I get 7/35, and then I get 5/35. This is addition, so I have 7/35 plus 5/35. Okay, 7 plus 5, 12/35. And I want to know, can I simplify this? Okay. Well, 12 is even, 35 is odd. See, they can't be simplified by 2. A number that ends in 5 or 0 is simplifiable by 5. 35 ends in 5, but 12 ends in 2. So it's not divisible by 5. And let's look at 3. How do I know something's divisible by 3? Okay. 12 is divisible by 3, but is 35 divisible by 3? Remember, they have to be the same number. Well, 35 is 3 plus 5, which is 8. Okay? So in order for it to be divisible by 3, if you add the numbers together, that result needs to be a number divisible by 3. 8 is not divisible by 3. Therefore, it is not divisible by 3, and we are good to go. All right, so here's a couple of other things here, all right? If we get a problem that looks like this, we want to go ahead and make the whole number piece over 1. Okay? That allows us to go ahead and get a common denominator and add them together. In this case, my LCD is going to be 11 because 1 could be multiplied and made into any number out there. So when I multiply top and bottom by 11, I get 33/11, and I'm going to add it to 8/11. Okay? Now 33 plus 8, 41/11. 11 is prime. So 11 is also that fun number that when we do the multiples all the way up through 9, it's a double digit that matches. Okay, 41 is not divisible by 11 because 11 times 4 is 44. I am done. Go ahead and give this one a try. Again, here, pause. Work on it. And I will see you on the other side. Use all the tricks that we talked about. Okay, first thing I want to do is find my LCD. And what I want to know is, first of all, my LCD has to be greater than or equal to 32. Okay, and I want to ask myself, can I multiply both the 16 and the 8 by something to get to 32? Okay, well, I know 8 times 2 is 16. All right, so I know I can make the 8 into the 16. And I also know that 8 times 4 is 32. So I know 8 times 2 is 16. I know 8 times 4 is 32. And that also must mean that the 16, if multiplied by 2, will give me 32, because that's twice that. 2 is 2 times 2 and 4. 2 times 2 is equal to 4. Hope that made sense. Right? So all of these can be made into 32. All right? Now 32, right here, has a 1 on top, so we're not going to change that fraction. So 1 over 32 is going to stay. All right. The 8 over 16, 16 needs to be multiplied by 2 to get to 32. So when I go ahead and multiply top and bottom by 2, I get 16 over 32. And that's added to it. My 1 over 8, I need to multiply by 4 to get to 32. So I have 4 over 32, and that's subtraction. So I am working with the denominator of 32. And I have 16 and 1 added together minus 4. 1 plus 16 is 17. 17 minus 4 is 13 over 32. And we are done here. This fraction does not simplify. Right? So go ahead and keep practicing on it, and I'll see you in the next video.